We're Team 11. We did a programmable lab power supply. My name is James Staley. My role was hardware integration and analog design, so I designed most of the analog circuitry that goes in here. Matt did our UI. He completely wrote the API for this. He's pretty much the star of the show as far as getting this thing to where you can push stuff in and it displays it on screen and then outputs it. Madison, she did the case. She did a lot of the team management and organization for us. Worked with Zach on the circuit board, making sure everything would line up. VJ is the man. He got 30 ppm of accuracy out of this thing. That's just astounding. Zach did all of our part ordering, got everything in on time, and he did the circuit boards so that everything kind of glues together, lines up with the case, lines up with the stuff inside the box. The problem that our project solves is taking something that's not really available in the market, that is safe programmable power supplies and active loads, and integrating them in a way that's affordable for the education market, for the professional hobbyist, at a price point that they can afford. Maddie was kind of our unofficial project manager. She did a lot to keep us all focused. In the beginning, you know, the two code guys and the hardware guy, you know, we were all trying to get our ideas implemented, and Maddie played a very important role in terms of keeping us all focused, making sure that where there were professional disagreements, we could analyze them logically and make a good determination about what kind of compromise we should go with. We wanted to get everything in one box. We wanted to use one microcontroller for cost, and we wanted to, first and foremost, make it safe. This is going to be for an educational market. That means there are people who aren't going to be fully aware of lab safety protocols, so we wanted to make sure that first and foremost they couldn't hurt themselves or start a fire with this, and we were successful at that. We've got everything in one box. It's simple to use. There's an easy, intuitive interface, and again, it's safety. We have got two basic ideal voltage sources, two ideal current sources. They're all galvanically isolated, floating with respect to the chassis. You can't shock yourself, you can't start a fire. If you were a person who'd never used a power supply before, and let's say this is your first day in a lab class, if you wanted to operate this, we have several features. There is a main power switch in the back that has a circuit breaker built into it. If anything else goes wrong, as a final line of defense against a fire, that will open up in the circuit breaker in the back. When you've activated this, you'd push the power button, and this will light up, the screen will initialize, and you would push select to enter the voltage. You would clear the voltage, and that clears the field, and then you would select the voltage 10 point, let's say 5, and if you want to adjust it from there, you can increment or decrement the value, and then you push to enter as it's placarded. Then finally you enable or disable by pushing the enable button. The hardest challenge for our group was we developed a lab quality piece of equipment. It's very precise, very safe, and we did it from the ground up. There's no commercially available products in here. We developed everything ourselves. There's umpteen pages of schematics that we all had to develop. We had to brainstorm, we had to come together, agree on what features we wanted, and the fact that we did all this in basically one semester is, I think we're all pretty proud of our accomplishment.